Hello, everybody, and welcome to your first lesson on the new book. It's called Sampling, and it's green. So the first page is your vocabulary list. This is going to be a lengthy one, but we have very little notes. We're going to do most of these things in class. So, all right, so sampling, word bank. Sampling is done for statistics. Learned about probability, and now we're moving on. This is connected to probability statistics, how to interpret data. And data is just numbers that you collect. It could be your test scores, your homework scores. Canvas is a big spreadsheet of data, all your numbers you collect, all your points you get. And so we're going to learn how to interpret that data. And one of the ways to display data is in a box plot. A box plot is a way to organize a group of numbers, which is data, using what's called a 5-number summary. Okay, and I'll show you how to find those 5 numbers. And so a picture of a box plot, you might have heard box and whisker plot, because at the end of this line, sometimes it looks like whiskers, and then you have, not always in the center. Please don't think this box has to be in the middle. It doesn't. And then it has a line right here. And the 5 numbers you'll need go here, 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 and here. You notice that box is not centered. It might be, sometimes it is, but it doesn't have to be, so don't assume. So that's called a box and whisker plot or box plot, and we're going to figure out what numbers these 5 numbers are, okay? A dot plot is a chart, is another way, a chart to organize data. Using dots for each number. And the way it looks, it's like a little open rectangle, and then you have a number line here, and then you put a dot on top how many times that number occurs. It's kind of like that. The 5-number summary that we talked about up here, that those numbers right here is 5 numbers that describe the spread of data. How far spread out is the data? Did you, when you look at all your grades, do you sometimes have very high grades and then low grades? That means they're very spread out. They're not always kind of in the same range. So here are the 5 numbers. They're called minimum, the minimum number, Minimum is the smallest number. The maximum, that's the biggest number in your data set. That would be your highest score you had on some test or assignment. And then you have the median, which is the middle number, the one that's in the middle when you order the numbers. And then we have quartile 1, which I'll show you what that is, and quartile 3. These are the medians of the lower half of the numbers, and this is the median of the upper half of the numbers. So these are 5 points that go here: minimum, maximum, median, and quartile 1, quartile 2. That's how they're located. Okay. The interquartile range are the numbers. By the way, one thing I need to tell you, when you do these, you always put the numbers in order from the least to the largest, from the smallest to the largest. From Q1, this is called Q sub 1. That's a way to write quartile 1. You put the 1 a little lower. So you have your quartile, that's the Q. And then the 1 goes a little bit below to Q sub 3. So in other words, it's all the numbers inside the box. So these numbers that are from here to here inside the box are the interquartile range. And these numbers make up half of all the numbers that you are looking at. So 50% of all the data points are inside that box. I don't have a picture for that. So let's go to mean. Mean is the average of numbers. The average, and what you do is you find the sum of all the numbers and you divide by the count. In other words, you add up all your numbers and divide by how many numbers there are. And the symbol is X with a bar above it. Okay. Oh, I should change my colors again. So I'm going to give you an example of finding the average. So let's say we have, by the way, when you find the average, your numbers do not have to be in order, but they have to be in order for everything else. So you might as well put them in order. So let's say you have numbers 5, 9. I'm just making up numbers 3 and 2. Those are your scores on some assignments, right? And you want to know your average. You add all these numbers. And then you divide by how many there are. There are 4. 5 plus 9 is 14, plus 3 is 17, plus 2 is 19. And when you divide that, you'd use your calculator. You can use your calculator in this whole book. I would suggest you use your calculator. It's going to be otherwise very lengthy. So your average is 4.75 when you divide 19 divided by 4. Okay, so that would be X bar. We call it X bar. The mean absolute deviation, the short, sometimes you'll see MAD, mean absolute deviation. And a deviation tells you how spread out the data is. So again, did we already? Yeah, spread of data. Up here we had the 5 number. It tells us the spread of data, but this one is a single number that we will have to calculate. So these were 5 numbers. This is a single number that, let's say, helps. No, I don't want to say helps. Let's say identifies how spread out the data is. So for an example, if the MAD, let's say, is 7.3, and another data set has a MAD of 2.6, this one is more spread out. That means your range is bigger. So the bigger the number, the more the data spread out. And this means you have a bigger variety of numbers. They're not all clustered. So let's say, let's go back to your school scores, your tests, your homework assignments. So let's say somebody is continuously getting the same scores. It might not be an A or a B, but you know, it's always kind of the same, good or bad, but you're never fluctuating in your scores. Your MAD score will be very low because the numbers aren't spread out. But somebody else might have good and bad days and they get A's on one day, and then the next day they're really having a hard time and they get a very low score. Those are going to have higher MAD scores because your numbers are more spread out. Okay. So again, we're going to learn how to compute that score in class. The median is, by the way, the median is Q sub 2, which is, I didn't list it here because it's quartile 2, because I named it median. Let's say, so you understand, we have quartile 1, we have quartile 2, and quartile 3. The median is quartile 2. That's another word. So that would be right here. Quartile 1, 2, quartile 3. This should be a 3. So I made a mistake here. Just notice that. Can you all fix it, please? This is 1. The median would be the second, and this is the third. So the median is the middle number. My thing has a mind of its own. If you put them in order, the middle number, nope, I'm going to use a different color. If you guys use a different color, that's good too. The middle number in the data, so you have to put them in order and line them up. So you have to count like from left and to right, and where you meet in the middle, that's the median. Numbers must be in order. And it's from the smallest to the largest. So I'll put it, yeah. For the median, the numbers must be in order, and then you can kind of identify the middle number. So let's see, I have an example. So again, I made up a data set. You're wondering, where do I get these numbers from? I just made them up. And notice each data has a comma between, and they are spread out pretty good because I don't like them bunched together. And these are in order from smallest to largest. Now this is an odd number of data, 5 of them. It's easy to identify the middle, right? 2 this way, 2 that way. Okay. So if you had another number, let's say I'm adding one more, I'll say I'll add 30, right? I'm just showing you, you don't need to write that. Then the 2 here would be your middle, but you have to find the average of those 2. That means you add them and divide by 2. So now 12 plus 20 is 32. 32 divided by 2, I think, is 16. Then the median would be 16. So that's how you do it when you have an even number, okay, of data points. These are called data points or data, okay? So the mode over here is the number that occurs most often in your data points. But sometimes there is no mode because every number is 1. See, there is no mode here. Sometimes there is no mode if every number is the same. Then you just say no mode. Okay, the word mode goes with most. The word mean goes with average. And the word median goes with middle. That's kind of how you can remember what they are. Yeah, those 3 words you got to remember. And you have an IXL assignment on that. So, and I'm going to give you a couple examples real quick at the end of this lesson, if I have time. So for example, do I have a mode? Let's see. For mode, they don't have to be in order, but 5, 7, 15, 17, 0, 15. Notice 15 is twice. That's your mode. Okay. Okay, population. Population is a group of objects. Like sometimes it's people. Any group. Or similar items. I don't have an example. Well, let's just come up with people, diseases, anything you can think of that it can be different objects or similar items. Did I spell this right? Diseases. Don't even know. Diseases. Let's erase it. I don't want to make a fool out of myself. Don't know how to spell diseases. I'll just leave that one example. Range of a data set. So this is, the range is also important. To find the range, you take the largest number minus the smallest number. In the data set. So it's the maximum number minus the minimum number is equal to the range. Okay. A sample is a smaller part of a population. So for example, if you think about a big high school and you want to find out what students, all the students at the high, let's say there's 2,000 students. That's a very normal high school number. And you wanted to know what they prefer, if they like the cafeteria food. And so you wouldn't ask every single student, you could pick a sample of students, a smaller group, and ask them, and then hopefully project it toward the larger population, that you hopefully picked a good enough sample that represents the whole population. Yeah, so you have to think about what sample. Okay, so in my example is I came up with, let's say you have a study, the weight of, you study, or you want to, the weight of Americans. Am I not going to study every single one? You're not going to go to every 1,000 and say, how do you do this? Do you exercise? Do you eat? What do you eat? You pick a sample, a small portion. Now, the key is your sample should be representative of the whole population. Okay. Stimulation, you probably heard this word before from airplane simulations, or when you go into space, they have simulations, what will happen. It's a way to model, a way to model, so you don't actually do it, random events. So for example, weather forecasting is a simulation. They simulate how the weather behaved in the past, and they projected what it could do in the future. And flight simulators, you heard before, hopefully. And there's more, so I'm going to say etc. So this is the vocabulary list of the words you might encounter in this book. And you'll need for your vocabulary quiz at the end. Okay, make sure you understand these words, read them again. Now, like I said, you're not having a bunch of notes in this book because most of this has to be done in class. Okay, so, but this one is indeed notes, this page. That's probably the only one pretty much. We will use measures of center. That's your like your spread and spread to describe data points. Where is the data centered? That's usually your median, your middle number. Yeah. We will make predictions about a population based on a sample of the population. Remember, I talked about you only ask a few people, you're not asking everybody because the population is usually very big. We will display data sets using dot plots, box plots, and other visual representations. Our goal today is to review statistics. Actually, I should say not today because you're going to do this in class on Monday and next week. Review statistics used it to summarize center and spread. Remember, center again is the median, the middle, yeah, of a numerical data set. So that's just numbers, yeah. Use random sampling to make valid inferences or predictions, yeah, about populations. Use dot plots, box plots, and other visual representations to understand and compare numerical data sets. The warm-up is a review from last book, so I thought this should be easy for you. Pretend you are doing a probability experiment with a paper bag that has 5 blue and 3 red counters. It's same like marbles. So if you don't know the word counters, marblers, what am I writing? Think of marbles. I'll just use the word counters. It's like a little coin, okay? Each time you draw a counter, you record its color and then replace it. So that makes it independent. Because it's each draw, you have the same shot. You have the same basic probability of getting that color. Independent trials, because you're putting it back. If you would take it out and keep it out, the whole thing would change, because now you're having one less counter, yeah, and one less color. So you have to adjust everything. So this is not, we're going to replace it, put it back. What is the probability? You will draw a blue counter. So remember, the probability is the part over the total. So you always have to find the total numbers that are there. 5 plus 3 is 8. So you have something out of 8, right? Blue, 5 out of 8. So I'm going to call it probability blue. What is the probability? You will draw a red counter, 3. Probability red, 3 out of 8. You can find the decimal and the percent. Remember, the decimal you divide. Use a calculator. The percent, you can either move the decimal 2 spaces to the right, or you can multiply by 100. So you have 62.5% chance of drawing a blue. And you can do the same with this. Same, change it to decimal percent. Here's the problem. If this is called a prediction, remember they talked about predicting. If you have 80 counters, you might not have 80 counters. This is your population. So the whole thing, right? How many would you expect to be blue? Well, you have 62.5% chance of getting a blue. Well, if you have 80, that should stay the same. So I'm going to find 62.5% of 80. And so the math is, you'd use the decimal, make sure you have a calculator, and you multiply by 80. And that gives you the number of counters. And I believe that's 50. Use your calculator and try it. And I'm going to say 50 counters might be blue, because it's always a little off. As we have seen in class experiments, it never works out exactly until you do it a million times. Okay. So that's the prediction. This is the population. If you draw 800 counters, now that's even more. You're not going to do that. You're not going to sit there and draw all these counters out of that paper bag. You're going to use your small sample group that you had. You had 8 counters, and you use your experiment to predict. So then you would do, you would find 62.5% of 800, and it's the same. Oh no, we want red, so we have to find that. Red, okay, 3 divided by 8 is 0.375, which is 37.5%. But when you do the math, you use the decimal. You multiply by 800. This means multiply. And use your calculator, please. When you do, you get 300. 300 of them might be red. For problems 3 and 4 above, do you think you would get exactly the numbers you wrote as in your answers? No, because that's why I wrote might. That's called theoretical probability. In theory, the real life might be a little bit off, but it's not off that much. in real life. It'll be off a little. Okay. Eddie drew 10 counters and all of them were blue. For the 11th turn, what is the probability of drawing a blue counter? It's the same as before. So because each trial is independent, so it's always a new game. Independent of the previous one. Chances are new, or it's the same. Each time. Okay, so Eddie drew 10 counters. Oh, he had, okay. What is the probability of drawing a blue counter? And so we need, blue was 0.625 out of 10. So 0.625 times 10, because he drew 10 counters, and that's 6.25 counters. No, what am I doing? 6 point, what is the probability? Nope, that's not right. For his 11th turn. Okay, so we'd have the probability would be again 62. We want blue, 62.5%. Which is the same as up here. Okay, this is page 1, and I have the next page marked for in class, and the next one also. So put in class, be there, please. We're gonna do this. You have to be there though. And this one in class, we're learning about how to find the mean, the range, the mode, all of these, right? Very important. So we're going to do that. And then we're going to be on page 4, that's in class. You're going to find your name score. That's going to be interesting. See the average, the X bar. You're going to find the average name scores. It's going to be easy. Don't worry. Not too much math involved. This whole math can be done with adding and subtracting, multiplying and dividing. There's not. And then this one is page 5 is in class. This is going to be homework, but it won't be until after you do. So I'm going to say in class because I don't want you to think you have to do that today for homework. You wouldn't be able to answer those yet until we do the lessons. So then we're done with lesson 1. So I made up a couple, I'm giving you an IXL assignment, and I wanted to show you a few things. So this is 7th grade IXL, CC1. Okay, and it's asking you to find the average, the mean average. So you have to add all the numbers and divide by how many there are. An architecture student measured 7 doors in some Victorian homes and recorded the following width. So you have to add these, use your calculators, and then you, in the end, the sum you divide by 7. Yeah. So I'm going to pause the video. You can try it and I will try it. Okay, so I found the sum is 294, and then you divide by how many doors there are. There's 7, and the answer is 42. So that's the average. Some of the question might say round to the nearest tenth. You have to know how to round up and down. Otherwise, you're going to still get it wrong. The median is the middle number, but you have to put them in order. Put in order. So I'm picking the smallest. 0, I cross them out. 0, you got to list both. That's probably, oh. So then it comes 2. I always cross them out so that 2, I know when I'm done. Then comes 4, 2 of them. 6, then comes 5, 1 of them. 6, 7, and 9. So when you do this activity, you should have pencil and paper to do that, because otherwise it's awful hard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's an even number. So the 2 middle number is 4 and 4. See how I have 4 this way and 4 that way? So it's 4. If this was, let's say, a 5, you would go 4 plus 5 is 9 divided by 2 would be 4.5, but it's not. It's 5. It's 4. Okay, so that's the median. And then last we have the mode, the one that's most often. 76, 72, 80, 80, 80. So I wanted to show you the range because I didn't get one that says range. If it does ask for the range, you take the highest number minus the smallest. So this is the highest minus the smallest, right? These two. And that would be 8. So your range would be 8. All right, and then last but not least, this is the part with these books that is a little different. You have actually homework at the end. Remember those skill builders. So this is page 22. Your homework is skill builder 1. So these are reviews you can do actually. So that's why I'm giving them to you for homework. Here you have to circle the error and rework the solution. So here you work it out correctly. There's an error somewhere here. Step 1, step 2, you have to kind of work. I would say work it out first and then look for the error. Okay. So let me go to that page so I can give you some instructions real quick. Yep. And then I just want to give you some examples so you're not totally lost. This is called the cross product. You multiply, it's a proportion. X times 15 is 15x equals 5 times 21. 5 times 21, you have to multiply that. It's 105, I believe. And then you divide by 15. 105 divided by 15 is 7. So that's how these work. And this is one of those chunking problems. You can draw a picture. She uses red and yellow. She's mixing paint. She's making orange dye, right? She's mixing yellow and red. The red is named first, so that means this is 1 part red and 3 parts yellow. So a picture sometimes helps. And now how much of these does she need to make 20? Each one is 1 quart. 1 quart, 1 quart, 1 quart. So there's already 4 quarts. So how much red dye and yellow dye will she need if she wants to make 20 quarts? She's already got 4 here, right? So figure that out with chunking, it's easy. The next page is Skill Builder 2. You don't have to do 5 and 6, but I wanted you to see a shortcut. When you have these decimals, you can just move your decimal one spot and rewrite if that helps. And make them whole numbers instead of these decimals, right? Do you see that? That's a little trick. So all I did was move each decimal one space and they're gone. And it's still the same problem. And here you have to distribute, multiply that out. You're solving equations, right? Here you can also change your decimals to whole numbers. I'm going to show you this in class. I know this is a little tricky here. You don't have to do these two. Okay, this is a, I want to show, well, you know what? Any of these that you don't understand, make sure you ask me in class, because I don't want you to have any wrong answers. So that's not a shame. That's a good thing to ask if you have any questions. And I'm sure you do. These are not easy. And then Skill Builder 3 also. Okay. These down here are PEMDAS. You have to use, please excuse my dear Aunt Sally. So parentheses always first. Exponents are the powers. I don't see any. Oh yeah, there's an exponent. You do that. Then multiplying and dividing are in the middle, but these are equally important, whichever comes first in the problem. Adding and subtracting are always last. Again, these are equally important to each other, whichever comes first in the problem. So try these. That's it. It's quite a bit, right, guys? Gives you something to do today and tomorrow.